In today's video, I would like to introduce you a very nice problem. It's coming from Estonian Mathematics Olympiad edition 1998. Here is the following equation. We have x squared plus number 1 equals logarithm of the base 2 of x plus number 2 minus 2x. Okay? In fact, this is very nice and interesting equation to work on. I'm going to apply just normal tricks, and at the end you will have this equation solved quickly. Okay? Just we are going to follow a couple of steps. The first step, we are going to respect the restriction of this domain range. X must be strictly superior than minus 2, because we don't need any negative numbers inside of this logarithm function. So this is the first step. Before we move on to the solution, I would like to remind you, do not forget to support the channel by likes and comments. So now let's get into it. Okay, so as I said, the first step, we are going to respect this restriction points. X must be strictly superior than minus 2. This is the first step. The second step, we are going to get rid of the logarithm. We need to cancel out this logarithm and reduce the equation to the smallest expression possible. Okay, now, so to solve this equation, I'm not going to go through all the details. I'm going to do it quickly. So applying the logarithm rule here, we get log of x plus 2 over log of 2. Then multiply this log of 2 by this one. I get the following. I get x squared plus number 1 is multiplied by log of 2, which equals a log of x plus number 2 minus 2x is multiplied by log of 2. So putting this one into the original one, putting this one in the original exponent, because this one, it was an exponent before we distribute this one. So which means I get the following. I get log of 2 to the x squared plus number 1. For the right hand side of this equation, I will have a log of x plus 2 all over to the 2x. So it's more simple in putting this one together under one logarithm function. So because you have minus sign here, so I will have a log of x plus 2 over log of 2 to the 2x, because this one also is going to be in exponent. Okay, so now I get logarithm on both sides. I'm going to get rid of the logarithm, canceling logarithm out of there. So we get the following. I get the expression of 2 is multiplied by x squared plus number 1 is multiplied by 2 to the 2x, which equals x plus 2. Okay, it's more simple here. We get shared base. We get this one has the same base, number 2. Let's put this exponent together. I get x squared plus 2x plus number 1, which is the quadratic binomial. So I get the following. I get 2 to the x plus number 1 quadratic square, which equals x plus number 2. Okay, so I have this nice expression. Let's get this one at the top and continue on this one. Previously we were working on this equation and came up with this nice expression. So here is the issue. The good news here, we have a reduced expression. It's more simple. But the bad news, we have no relationship between the left and the right side of this equation, because the left hand side of this equation is involving the exponential function, but the right hand side of this equation is involving the linear function. Each one works differently. Okay, each one works differently. In order to make it more simple, we are going to go through substitution. What's the appropriate substitution we can put? If we put in x plus number 1 equals something, is not going to help. But I'm going to take the whole expression. If we put also the whole expression, which is an exponent x plus number 1 quadratic square equal the new variable, also is not going to help. To put x, let's set x plus number 1 quadratic square equals 2 times 0. Now remember here, we are going to take the square root on both sides. You will have two different values. We get positive value if you have this one positive. You get negative value if you have this negative. So which means I get x plus number 1. After I took in the square root, I will get two things here. I get square root of 2z, and also I get minus square root of 2z. But this one will be happen. This one is going to be happened if x is superior equal to minus 1. This one if x is strictly than minus 1. So both of them, they are sharing number minus 1 as a common solution here, because replacing x with minus 1, I get 0 here. Also, I get 0 here. Okay. I get also 0 because 0 equals 0 also. So keep in mind here also z must be super equal to 0. Z is super equal to 0, which means we are allowed to put 0 inside of the square root because we are considering this equation has the solution in the integer numbers. Okay, let's continue working on this one now. So now the next thing up, I'm going to take this new variable and put it into the original equation to have a new expression. So I get the following: I get 2 to the 2z, which equals x plus number 1. It will be replaced with square root of 2z, then plus an additional number 1. So for the second expression I get almost the same thing, but this term will, one of the term will be negative, which is minus square root of 2z plus the number 1. Now I'm going to apply two different tricks. The first equation, I'm going to apply the difference of two squares, since I have this one is a perfect square. By moving over this one to the left, I have a difference of squares, and we will factor that out on the form of the product. I will have a nice expression. But the second equation, since I have a negative sign here, by moving over this one to the left, I will have inequality. I'm going to apply the inequality here. So for the first equation, I get the following expressions. I get 2 to the z minus 1 factor 2 to the z plus number 1, which equals square root of 2z. For the second equation, I will have 2 to the 2z. Moving over this number 1 to the left becomes minus 1, which equals minus square root of 2z. So I'm going to apply a nice game here. Let's start in with the second equation. Second equation, it's clearly is going to be negative, but which condition this one must be negative? We know the square root is positive. In order to have this one negative, we need this one to have it positive. Okay, in order to have this one negative, we need to have this one negative as well to have equality. But if this one is positive, is a problem. It's impossible. So this one let's make this one impossible if z is super equal to number 1. This one is strictly impossible. Why? Because replacing z with number 1, I get 2 minus 1, which is 1, is a positive, but this one is negative. Okay, so let's check if so in order to maintain this equation and make it work correctly, we need to give z 0. If we give z 0, I get 2 to the 0, which is 1. 1 minus 1 is 0. Also this one, it will have 0. 0 equals 0, which is fine. Okay, so which means I will have the solution at the 0. Z equals 0. For the second equation, let's check the second equation as well. So the next trick, I'm going to raise number 2 as a power on both sides. I'm going to cancel out this square root. Now let's work out doing the same thing. If z is super equal to 1, if z is super equal to 1, this one becomes odd. This one also is odd. We know odd is multiplied by odd is going to give us odd, but this one is even. What does mean? This means impossible. So where we have a possibility to have a solution, when this one become possible if only if we give z equals 0. If z equals 0, take a look at here. Z equals 0, this one becomes 1 minus 1 is 0. But we don't care about this one. This one is positive, even though with z equals 0 here. We get number 2 is multiplied by 0 is 0. Also replacing z with 0, get 0, which is fine. Now also I get z equals 0 is a solution. Let's combine this one together. I get z equals 0 in the second equation. Also I get z equals 0 in the first equation, which means the whole thing z equals 0 as a solution for this equation. But remember, we are not working for the z as a variable, we are working on x as a variable. So in order to solve this equation, I'm simply replace z with 0. I get 0. If z equals 0, which means this one equals 0. If this one equals 0, which means x equals minus 1. X equals minus 1. Okay? x equals minus 1, we are fine because we have still are working on the domain range. So which means x equals minus 1 is a solution for this equation. Now we found one solution for this equation as an integer. Okay. So now we have done with this problem. By the way, don't forget to hit the subscribe button and support our channel. And thank you for watching. I will see you next video. Bye.